Hi, in this video we're going to talk about the last aspect as far as fill factor and page splits are concerned, and that has to do with addressing the performance impact of having a fill factor other than 100%. Now, as I mentioned, this is in response to another video that was presented recently, and in there it was suggested that when you do fill factor anything other than 100%, the additional number of pages that get allocated slow down the performance of backups and CheckDB, and overall increases the size of the database. And that makes sense because that's exactly what a page split does. It breaks a page into multiple pages. Now the fact is, just because it does that doesn't necessarily mean it's a bad thing for us, and I'm going to try and demonstrate that in this video. So I've already done the measurements over here. So if you look over here, the notepad that you see here on the left hand side is the data when the fill factor is at 70%, and the one on the right hand side is when the fill factor is 100%. So what I want to try and show you here is, if you look over here, I've got a database called my data, and the size of the database is 3.8 GB basically, and that size remains the same because as far as the database is concerned, we have to take into account the allocated as well as unallocated space. And you can see here in this case the unallocated space is less compared to that for 100% fill factor. So that just means that autogrowth has less chance of running with 100%. Now that's not necessarily a bad thing, as we know, but I'm just calling it out that yes, because of the additional number of pages being allocated, there is a slightly larger size in the database table. We'll also see that as far as the data in the table itself is concerned, I've got a table called orders, and what you're seeing here is basically the space used by that. Now the other thing I want to try and show you is, as far as you can see that the size of the table is also significant, about I guess, what is it, 500 MB more than with a fill factor of 70%. So definitely the size of the table is going to be large. That's something we can accept as a valid and genuine point. Now you can also see that when it comes to database backups, when you have a fill factor of 70%, you'll see that the time taken to complete the backup with 70% fill factor is 39 seconds because we've got 220,000 pages that needed to be read. Whereas with 100% fill factor, it's 28 seconds with about 161,000 pages. So yes, backups also take longer. I've run it twice just to get an average, and in both cases the fill factor with 70% does take about 10 seconds longer to complete. The next thing is the size of the backup itself doesn't really change much because of the compression, so we can leave that out of the equation. And then this is the time taken for CheckDB, and if I scroll down to the bottom of the results, you'll see that CheckDB took about 22 seconds to run here, and just give me a second, I'm going to scroll all the way down, and it took about 15 seconds here. So in terms of the time taken to complete these tasks, definitely it looks like fill factor makes things worse. But having said that, I want to show you that that's not something you want to worry about, because if you look at the size of the database, what we want to try and understand here is that storage is cheap, and we don't really need to worry so much about the amount of the size of the database on disk per se. Backups are taking longer, but this is a full backup, and it's something that you only do with an what do you call a service interval maintenance window. And again, this is something that you only do maybe once in 2 weeks. Majority of the time you're taking transaction lock backups, which do not have anything to do with fill factor. So having said that, it looks like backups are not really that big a concern. Obviously there are other ways to alleviate the problem. As far as CheckDB is concerned, again, CheckDB is something that you can run on pretty much any system, so it doesn't really matter. As long as you have always on running, you can run CheckDB on a secondary mirror, and that should be fine. And again, CheckDB is not something that you run very regularly. So what I'm trying to explain here is that even though fill factor does tend to contribute to the overall execution time of these maintenance operations, these are maintenance operations that are completely in your control. These are things that you can actually do something about. You have your maintenance window and you can plan it out properly. You have ways to stripe the backup. You have ways to run CheckDB with fewer options, or you could even just run CheckDB with its 3 internal dbcz commands separately. So there are ways that you can mitigate this particular problem. What you can't mitigate is this issue here. So if you look over here, what I'm trying to do is I've altered the index and set a fill factor of 100%, and then I'm running a query to insert 100,000 rows into the table. Let me just go ahead and show you that real quick. So this is a while loop with 100,000, and you can see that it's using a new ID, so it's just gonna go ahead and randomly insert some sequence into the data, causing the page split. Right, and I'm measuring the time taken for it, and then I'm also doing a fill factor of a 70% and running the same query again. And it's pretty clear over here. You can see the difference from the previous execution that I did. With a fill factor of 100%, the query took 56 seconds, and with the fill factor of 100%, it took 56 seconds, and with 70, it took 32 seconds. And this is something I have to deal with every day. This is not in my control, and that is why I want to take care of this issue rather than worry about stuff that I can do easily over a weekend. So I just wanted to call this out because it seemed like as if it was being made to look like a bigger deal than it was. When I was talking about the other video, it seemed like as if the presenter wanted you to kind of focus on the backups and the time taken for CheckDB, etc., when that definitely is a factor, but that is something that does not really affect the end user. And as a DBA, your focus should be on the end user experience in terms of the application scalability, in terms of being able to execute queries faster for the end user. So I would much rather fix the issue that I'm facing here in terms of being able to load a certain number of rows within a given time interval, rather than worry about something I have to do every 2 weeks or more, actually, to be honest. So I'm just going to leave this running in the background. What it's going to do is just run the whole thing and show you a demonstration of what I was trying to show as far as that query is concerned. And hopefully when this query is done, you'll appreciate the fact that not everything on the internet can be easily just taken and copy pasted onto your systems. You need to go ahead and evaluate things for yourself. So to summarize the topics that were being discussed in this series, page splits are definitely bad for your system, and you want to try and mitigate it, mainly because it takes away CPU and IO disk cycles, which you can't really afford to lose because the disk is pretty slow as it is. Having said that, the way that you want to measure page split is by using a counter called page splits per second, but having to use that counter on its own without a baseline is a mistake, because you need a baseline to see what would be considered a normal operational behavior and how to detect or how to compare that with when page splits happen, to kind of know the severity of the page split issue that you're facing. The third thing is, when you have that issue and you've identified that this is a problem that you want to fix, you need to go ahead and set an appropriate fill factor by measuring how much free space you need per page, depending on how frequently the page split happens and what is the amount of data that needs to be inserted. And secondly, page split on its own doesn't really fix anything. It's a combination of page split with a rebuild that will ensure that there is always sufficient free space in a page, and therefore doesn't cause the split to happen in the first place. The last thing I want to leave you with is basically the stuff I mentioned in this video, that when you use fill factor, definitely the size of the database, the size of the not the size of the backup, but the time taken to do a backup, the time taken to detect CheckDB are gonna increase, but that's something that you only have to deal with once in a while. The problem that you're more likely to face is the one that I'm just showing you here on the screen, where you can see a fill factor of 100% took about 67 seconds to complete, whereas a fill factor of 70 took about 10 seconds to complete. And that's a huge difference, and that's something that you'll have to deal with every single day, and that's what you should be focusing your energies on. So I hope this video kind of gave you the context, gave you some information, and set you right in terms of what you should be doing with page splits and fill factor. Turned out to be a much longer video than I expected for a topic that was fairly simple, but I wanted to be thorough, and I hope you've enjoyed this video. Thank you for watching.